Welcome everyone to part 2, vertically shifting the generalized logistic function. So as we saw in the last example, the current formulation of the generalized logistic function did not fit this second case wave from Australia very well. The prediction line is continuing up and to the right, and it's not curling over and heading towards an asymptote as we would expect. So the reason for this is that the cases at the very beginning do not begin at 0. Our model expects cases to begin at 0. So this is throwing our model off because we're modeling the second wave, and the second wave does not have cases that begin at 0. So the way to handle this is to allow for a vertical shift with a new parameter that we're going to call s. We're just going to add s over here, and that's the main part of the parameter. You can also subtract it here as well on top so that the asymptote in fact is going to be exactly L. So that's what we're going to do, and we're going to create a function called the general logistic shift, and we just add it in over here and over here. So we will call the predict all again, which is very nice. We just drop in whatever our new function is and the new bounds. So for our new bounds, what we will do here is these parameters are going to have pretty much the same range. Now for s, we will allow it to be anywhere from 0 to the very last case number, and we'll allow the optimizer to figure out, all right, how far it should shift up or down, or really up since the minimum is 0. So we're going to create our bounds. We'll just guess the minimum here. It's not too terribly important. You could guess the very first value, but we're just going to guess 0 as the amount to shift up. So we're going to call our predict all. And as we can see here, it does not quite make a good fit, obviously. But what it does do is it does follow the trajectory of the cases like we would expect. So it's going up and it's curling over to the right towards some asymptote. So it's not giving this strange model where it's going up and then still increasing over here. It's following a typical trajectory of a coronavirus case wave and heading towards some asymptote. And one of the reasons why it didn't actually make a good fit is that at August 1st, it's right near its inflection point, so it could very well, if you only saw up to August 1st, it could very well have exploded up a little bit more before finally curling over to the right. But what happened in actuality was that it just happened to curl over faster. Now, if we gave it a little bit more data, say up until the middle of August, then it would have found that out. So we could, if we change this to say August 14th, we'll see that by this point, it was more obvious that the cases were in a decline, and so the model finds a much tighter fit and a much better prediction. So let's go ahead and look at the values that it found. So it found that, so if you look over here, it's probably very close to that very first value. This is 6,600. If we look at the cases of the start date, we'll see that, yeah, so it's most likely going to be pretty close to that very first value. So that's how much it shifted up. And then, the other values it found like that. Okay, so that's our new model. We added this parameter s to vertically shift up our generalized logistic function.